Okay, hello there. My name is Violina Helena Sapan. I'm from IF 46 INT class. And right now I'm going to explain problems about integrals related to trigonometric substitution and partial fraction. Okay, so for number one, part 3, we have to find the integral of square root of 1 plus square root of x over x dx. Okay, first let determine u. Let u be square root of x, and this is equal to x to the power of 1/2. And then we can derivate the u, so du equals 1/2 times x to the power of 1 minus 1/2, and this is equal to 1 over 2 square root of x dx. From this equation, we can get dx, substitute the u, we plug in the u to the square root of x here, we'll get this equation. Okay, next, we need to substitute in for x and dx. So yeah, x and dx here with u, right? We'll get this equation, and we can simplify this equation and pull out the 2. So it will become this. Next, to get rid of this tricky square root equation, we can use the simple substitution of v. Yeah, so let v be equal to the square root of 1 plus u, which is equal to 1 plus u to the power of 1/2. And from this equation, v equals the square root of 1 plus u, we can get u equals v squared minus 1. Okay, so after that, we can derivate the v. Okay, and we'll get this equation. So then we can get du equal to this. When we plug in the v to this, we can get this equation, 2v dv. So du is equal to 2v dv. Okay, next, we need to substitute in for u and du. Okay, so 2 times the integral of, and then times 2v dv, because du is 2v dv. Again, we can pull out 2, and this 2 will be multiplied by this 2, which is 4 times, okay. So we can manipulate this fraction to this. Okay, so if we make it like this, v squared minus 1 over v squared minus 1 plus 1 over v squared minus 1, it will be equal to this, right? So that's why v squared over v squared minus 1 is equal to 1 plus 1 over v squared minus 1. Okay, next, let's split up the integral. Okay, so the integral of 1 is equal to v, right? So we can write this for v, but for this part of integral, don't simplify it yet. So we can just write it down like this. Okay, so we'll get this 1, and we factorize this one, right? Into v plus 1 and v minus 1 dv. Okay. To calculate this type of integral, we can use the partial fraction formula. So this. So this is the original fraction, right? We can separate this into a fraction with the denominator v plus 1 and the other one with the denominator v minus 1. We can put a and b here. So the concept is this partial fraction will add up to this original fraction. Next, I want to clear up the denominator. So I will multiply both sides of the equation with the least common denominator, LCD. So the LCD in this case, is v plus 1 times v minus 1. We can thought of this one as 0v plus 1. And okay, and the denominator, I already multiplied the denominator with the LCD, so yeah, it equals to 1, right? So the equation will be 0v plus 1, and then this one will be. Okay, next, let's distribute the a and the b. This one, okay, this side of the equation. After that, we group the terms that have the v and the terms that doesn't have the v. Okay, in this case, I want the coefficient to be the same on the left and the right side of the equation. So yeah, the coefficient of v. Okay, so that means I can create this equation. A plus b equals 0. And I want to make the constant the same on both sides as well. So I can make this equation equals to 1. Okay. And we can use the standard algebra to calculate the a and the b. So this, we can eliminate the b, right? And so this will result into a equals minus 1. So a is equal to minus 1.5. And then in this case, we can substitute the a to this equation. So minus 1.5 plus b equals 0. So from this equation, we can get the b equal to 1.5. Okay. So after getting this equation, we can plug in the a and the b to solve for this integral. So we can write down the equation again. We can do this. We can get this equation for v plus 4 is the integral of, okay, substitute in the a with this value. So we'll get minus 1.5 over v plus 1 plus the b value is 1.5 over v minus 1 dv. Oh yeah, don't forget the dv here as well. Okay, so it will be equal to, so this time we can do it like this for v, and we can integrate this equation. So we pull out the minus 1.5 and multiply it by 4. which will be equal to minus 2. And then we can integrate the 1 over v plus 1, and it will result in, so this one will be minus 2 times the natural logarithm of absolute value of v plus 1. And then similarly, this 1.5, we can pull it out and multiply it by 4, which is equal to 2. And we can integrate the 1 over v minus 1, which is equal to the natural logarithm of absolute value of v minus 1 plus c. And then we need to substitute in for v. V is equal to square root of 1 plus u, right? So we can just write like this. And then we need to substitute in for u. U is equal to square root of x. So we will get this equation. Okay. This is the end of number 1, part 3. This is the result. Okay. Okay, so next we're going to solve number 2, part 2. We have to find the integral of dx over square root of x squared plus 2x plus 5. This will be equal to dx over, so we can manipulate this equation, and then this will be equal to dx over, we can transform this equation, x squared plus 2x plus 1, to square root of x plus 1 squared. So this equation will be transformed to x plus 1 squared because it's just the same, and then you can just plus 4. Okay. Next, we're going to use trigonometric substitution. First, we draw the right triangle with this angle, theta, and then we can put 2 here and x plus 1 here. X plus 1 squared plus 4. This is according to the Pythagorean theorem. So we will use the tan theta. Tan theta, according to the formula, is equal to the opposite side of the angle over the bottom side of the angle, or the bottom or the adjacent side of the angle. Next, we can find the x from this formula. The x will be equal to 2 tan theta minus 1. And then when we derive the x, it will be equal to 2 secant squared theta d theta. We got the dx. How about the square root of x plus 1 squared plus 4? Okay, so we will use the secant theta. Secant theta is equal to 1 over cos theta. So cos theta, the formula of cos theta for the right triangle is the adjacent side of the angle over the hypotenuse. So we get this equation. We can just multiply the secant theta with by 2. We get this. Okay, next, we can substitute in for dx and this equation. And we can simplify. So the integral of secant theta d theta is equal to, next, we can substitute in for secant x and tan x. And we can, okay, so in this case, the denominator is not included in the square root. So if we want to include the denominator in the square root, this will result in, okay, next, we can divide x plus 1 squared by 4 and this 4 by 4. And it will result in, okay, ta-da. Next, we're going to solve the problem for number 3, part 2. Okay, so we need to find this area. So how do we find this area? We need to find the integral of 15 over x squared plus 7x plus 12 with 2 and 1, with 2 as its upper bound and 1 as its lower bound. Okay, we can pull out the 15. So 15 times the integral of 1 over, okay, we can factorize this. We can factorize this to x plus 3, x plus 4, x plus 4 dx. Okay, so to calculate this integral, first we need to use the partial fraction formula. Okay, so this is the original fraction, right? So we can separate it to 1 with the x plus 3 denominator and 1 with the x plus 4 denominator, and this will be equal to, okay, we can thought of this one as 0x plus 1 over, okay, x plus 3 times x plus 4. Okay, and we can write a and b here. So to clear the denominator, we need to multiply both sides with LCD, the least common denominator. In this case, the least common denominator is x plus 3 times x plus 4. So after we multiply both sides, we will get this equation. And then we need to distribute this side. Okay, and then we need to group the term that have x and that don't have x. Yeah, we want the coefficient of x to be the same on both sides, right? So in this case, a plus b is equal to 0, and for, yeah, we want the constant to be the same as well on both sides. So we can write 4a plus 3b equals 1. Okay, so next, we can use algebra to solve for a and b. Okay, we can multiply both sides of this equation with 3. This one, okay. So the upper equation will be 3a plus 3b equals 0. This one will keep being like this. And we can eliminate the 3b. So 3a minus 4a equals minus a, 0 minus 1 minus 1. So a equals 1. And after we got a, we can substitute the a to this equation. So 1 plus b equals 0. So b equals 2 minus 1. Okay, let's write this equation again. Okay, so here, the partial fraction, we can plug in a equals 1 to this equation and b equals minus 1 to this equation. So we get, then we can integrate this. So 1 over x plus 3, the integral of 1 over x plus 3 is the natural logarithm of absolute of x plus 3. So this one, and the integral of 1 over x plus 4 equal to natural logarithm of absolute of x plus 4 with 2 as its upper bound and 1 as its lower bound. So to calculate this, we can do this. Okay, after we plug in the 2 and the 1 to this equation, we can calculate this equation, and we'll get this. So if, according to the logarithm rules, if we subtract the natural logarithm of 5 with natural logarithm of 6, subtraction will be a division between 5 and 6. So 5 divided by 6. So it will become this. We'll get this equation. And then natural logarithm of 5 over 6 subtracted by natural logarithm of 4 over 5 means this 5 over 6 will be divided by 4 over 5. So we'll get this, and it will result in, the result is 15 minus natural logarithm of 25 over 24. That's it. Okay. Yep. That's all from me. Thank you for paying attention and listening. I hope this video is useful for you. Okay. Thank you and bye.